a picture of the sample, which we don't have here. So if you're going to say they're not big enough, then you're going to say I would need to look at the sample to see the shape of it in order to proceed. Okay, but let's just say ends are big. Okay? All right, draw a picture. I already drew a curve for you over there. What's going in the middle? Good. Draw a vertical line for me. I don't know why I like that. Okay. Now what does she need to figure out? Where is she going to shade from? From what?
Yeah.
Go ahead.
Like the actual difference.
The difference in our
observation.
good. I'm not sure I want to call that the actual difference because we're looking for the actual difference. The difference in our samples, right? That's the one result we have from that picture of all possible results. So what is the difference in what were the results we got? Which one are we doing? Personal contact or involvement?
Personal contact.
Personal contact. So subtract the two. What do you get? Negative what? Everyone agree with that? Okay, negative 0.81. Should she say both sides or one side here? One side. Okay. Should she make a t-score or a z-score? T-score. But you understand the procedure is the same whether you're making a z-score or a t-score.
People ever just say, like, my sample size is so big that I might as well just use...
Yeah, were you in class last time?
Yeah.
Remember I told you that's how I learned it.
Okay.
Right? But that was before we were able to easily find p-values for t-scores.
Like, it's like 10,000 or something.
It really makes no... You're going to get the same answer. Yeah. All right. So what's your t-score? Write out the formula now. Signal versus noise, right? How much actual difference is there in the numerator over standard deviation? Okay? So just put your numbers in. So we have what? Negative 0.81 minus 0 over. Now she's going to need that formula, but she doesn't know sigma, right? So what are we doing? We're using S, right?
Yes.
Okay. So square root of okay. So put in the numbers for the numerator. So we have what squared over what? Square root of
0.93 squared.
1.03 squared over
48.
42 plus. Okay, good work. Okay, now either type all that in, or I would suggest, because you want to get the computer to give you a p-value anyway, that you hit stat, tests, and you go find a two-sample t-test. It will ask you here whether we are pooling. We don't pool t-tests, we're going to skip that. So you can leave no as for a t-test where it's going to ask you pool. Okay? So you need to put in your x bar 1. Where it says data and stats, you want it on stats. If you just have the data in the lists, you can do it directly from those with data. That's what that option is. Put all the information in. Hit draw. And it will calculate your t-score for you and give you a p-value. So now if you hit 2 sample z-test, it's asking you for sigma, but you don't know sigma, right? You're on the wrong screen because do you see it's asking you for sigma? That's because you're doing a 2 sample z-test, which you're never going to do.
Hold on, I have to do it.
Because that would require you to both
What
know
is this?
both standard deviations. You need to be doing a 2
Four.
sample t-test. Yeah.
We pull them if you're like assuming that's the same exact thing.
Well, really what that is assuming that the variances are the same.
Yeah.
But that requires another test
Yeah, I got this.
called the F-test,
Okay.
which we probably won't have time for. So
What did it call? Calculating the draw.
calculate just gives you the numbers, draws a picture, and gives you the
So you make second row statistics.
Yeah.
Ew, I gotta send this.
All right. Does anybody have an answer here? What's the t-score? Did anybody else get that? 3.89. P-value, pretty small, right? 3.89 standard deviations. What's the p-value? 0.0001. Okay. Now, one point of technical